Loran Navigational Transmitter.
What is Loran? Loran, short for long-range navigation, was a hyperbolic radio navigation system developed in the United States during World War II. Hyperbolic navigation is navigation receiver instrument on a ship or aircraft is used to determine location based on the difference in timing of radio waves received from fixed land-based radio navigation beacon transmitters. Loran, in its original form, was an expensive system to implement requiring a cathode ray tube display. This limited use to military and large commercial users. Automated receivers became available in the 1950s, but the same improved electronic also opened the possibility of new systems with higher accuracy.
Types of Loran. First, the Loran B, which offered accuracy on the order of a few tenths of feet, but ran into significant technical problem and has not been used. Second, the Loran C, now known as for Loran A, or which we called Standard Loran, would become much more popular during this period and offered longer range than Loran and accuracy of hundreds of feet.
Problem. Loran Navigational Transmitter is positioned on A -150 x-intercept 0y intercept and B 150 x-intercept and 0y intercept. A receiver P on a naval ship is located on the hyperbolic path listens to the two transmitter in which the difference in distance is 240 kilometers. Determine the standard form of equation of the hyperbola by finding the coordinates and points of hyperbola.
Loran Navigational Transmitter is positioned at A -150 0 and B +150 0. A receiver on a naval ship located on the hyperbolic path that listens to the two transmitters in where the difference in distance is 240 kilometers.
Find the coordinates of different essential points of hyperbola.
Determine the standard form equation of the hyperbola. We must graph it first. Here our naval ship P, and we have our focus 1, which is the cosine of parenthesis 150 0, and our focus 2, which is cosine of parenthesis -150 0. And we have our center, which is the 240 kilometers, and the vertices, which is the closing open parenthesis -120 0 and closing open parenthesis 120 0.
Solutions.
We must find the value of B first. A equals to 120, B equals to, C equals to 150, B squared equals to C squared minus A squared. B equals to square root of 150 squared negative 120 squared. B equals to square root of 8,200. B equals to 90.
We can now determine the coordinates of different essential points of the hyperbola. We have here F +150 0 and our transverse axis, which is 240 kilometers, with F +120 0 and our center vertices is 0 +90.
Determine the standard form of equation of the hyperbola. We use the formula x squared over a squared minus y squared over b squared equals 1. Therefore, x squared over 120 squared minus y squared over 40 squared equals 1. We solve the 120 squared and the 40 squared. X squared over 14,400 minus y squared over 8,200 equals 1. Therefore, the standard form of the hyperbola is x squared over 14,400 minus x squared over 200 equals 1.